All right, let's look at number 1. In the figure below, point P is in the center of the larger circle, point R is in the center of the smaller circle, and P and R intersect at point T. So PR is 3 inches, they've told us. So I'm just going to label that over here. PR, this is 3 inches. So we need to do a couple of things. We want the area of the shaded part of the figure, which means we're going to have to find the area of the whole circle, or the, rather than whole, let me just say, I'm going to do the area of the big circle. And from it, I'm going to subtract away the white that's left out, which is the area of the small circle. And for both of these, we're going to use that area formula for a circle, which is pi r squared. All right, so area of the small, it's easy. They gave us r, because from r to p was a radius. So that's pi times 3 squared, or that's 9 pi. Area of the big, we have to think about it a little bit. Well, if P to R is 3, then R to T is also 3. That's a radius, which tells me that the whole thing from P to T is 6. And that makes 6 the radius of that circle. So pi times 6 squared will be the area of the big circle, or 36 pi. So what's 36 pi minus 9 pi? That's going to be 36 minus 9, which is actually 27 pi. Option C. Moving on to number 2. We have the figure below consisting of an isosceles triangle and 5 semicircles, each having the same diameter. And if the perimeter of the triangle is 60, what is the area of the shaded region? Okay, so all the way around the outside is 60, and these two are completely equal. And we want to know the area of the shaded region. Now, theoretically, the shaded region are just circles. We've got one circle up top, which is shaded. If I put the two halves back together, one circle at the bottom. If I take these two halves and put them together, and then I have an extra half. So if I could find the area of my circle, and then I could multiply that by 2.5 for 2.5 circles, then that's going to be the area of my shaded region. All right, so the hard part is, since we need the area of the circle, that's pi times r squared. Our hard part is finding r. So now we know all the way around the outside is 60. Well, we have 1, 2, 3, 4, 5 diameters that go around the outside of this circle. Of this triangle. So if we have 60 total, and I divide that by 5, that tells me that each diameter is 12 units. That's the diameter, or the distance across the circle. Diameter. So if my diameter is 12, that means my radius is half, or 6. All right, so now I know the area of a circle is 6. We've got pi times 6 squared, or 36 pi. And we want to multiply this by 2.5 because there are 2.5 circles. And if I take 36 times 2.5, I'm going to get 90. So 90 pi is the area of my 2.5 circles. All right, number 3. We're going to determine the perimeter of the isosceles right triangle. Isosceles. That means the two sides are equal. And it can't be the hypotenuse, so these two sides must be equal. And it's a right triangle because of that right angle symbol right there. So let's think about our special right triangles. We need to memorize that in a 45, 45, 90 degree triangle, the sides are x, x, x root 2. Which tells me that right here, this is x root 2. They're both the same. All right, 14 is x root 2. I'm going to go ahead and solve that because that's going to give me the other two sides. And I need these sides because I'm going to have to add them up to get that perimeter. So let me go ahead and solve root 2, root 2. We have x is 14 over root 2. We must get rid of this root 2 in the bottom because we're not allowed it there. So I'm going to multiply the top and the bottom by root 2. We get 14 root 2 over root 2 times root 2, which is root 4, which is 2. And now I can simplify my 14 and my 2, and that tells me 7 root 2. That's x. All right, so 7 root 2 is x. This side is 7 root 2. This side is 7 root 2. 7 root 2. And if I add them all up, 7 root 2 plus 7 root 2 plus this last side, which they already told me was 14. I've got 14. I'm going to move that to the front. And 7 and 7, that's 14. So I've got 14 root 2s. I can add the radicals because they have the exact same radicand. So that would be option B. Number 4. We got a regular hexagon inscribed in a circle with area 12 pi. So here we have a circle. Its area is 12 pi. And area is usually pi r squared. So if I go ahead and solve this right now, I'm going to divide by pi. So I've got 12 is r squared. So r is the square root of 12. I'm just going to leave that there for a second. So I know that the r is the square root of 12. Alright, so if I take a hexagon and inscribe it in here, this is not the most attractive hexagon. The radius of the circle is actually the radius of the hexagon as well. Now you guys might remember, hopefully, that what we did when we had a hexagon was we found that center, we drew a triangle, okay, so now we've kind of got a pop out. I'm going to draw it big right here. And we said that this angle at the top was 60 degrees because that was 360 divided by 6. So this one's 60 degrees. And we're going to drop down here 60 degrees, and we're going to drop down the apothem. And the apothem is going to make that right angle. So this is what we're looking for, the apothem. Now the radius of the circle is root 12. And root 12, if I simplify it, and feel free to pause at any point in time if this is too much, I'm going to do my factor tree. That's 4 times 3, which is 2 times 2. So these go inside. That's 2, and 3's left over, root 3. Okay, that's across from the 90, which means across from the 30, which is half of this angle. So across from the 30 is half of that, or just root 3. And the apothem, which is across from the 60, will be x, this number, times root 3. So this is going to be root 3, root 3. That's x root 3. Now root 3 times root 3 is just 3. And that is the length of the apothem for the hexagon. Alright, finally, number 5. The area of a triangle with sides 5, 12, and 13 is equal to the area of a rectangle with a width of 10 feet. And we want to know the perimeter of the rectangle. Alright, let's start off with this triangle they told us about. What kind of a triangle is this? A 5, 12, 13. Well, we can use the Pythagorean corollary to check. 13 squared, let me compare it to 5 squared plus 12 squared. This is 169. Compare it to 25 plus 144. And 25 plus 144 is 169. So these are equal, which makes this a right triangle. Okay, so now let me label this right triangle. It doesn't really matter where I put the sides. All I know is this has to be 13, and the other two sides are 5 and 12. And since it's got a right angle, this is the height and this is the base. So the area will equal 1/2 base, which is 12, times height, which is 5. So 1/2 of 12 is 6, and 6 times 5 is 30. So now we know the area of our triangle. Okay, now let's move on to the second part of the problem, which is this rectangle they're talking about. Now the rectangle has a width of 10. And they just told me that the area of this triangle, 30, is equal to the area of the rectangle, which means the area has to be 30. So what number is going to go right here? Well, what times 10 gives me 30? 10 times x is 30. That tells me that x is 3. I'm dividing both sides by 10 there. If that's 3, this is 3. And this is 10 because opposite sides are congruent. And the perimeter is when I add all those up, 3 plus 10 plus 3 plus 10, which is going to be 26. So that is our perimeter.